Hello, hello. I'm audible now, Akash. Hello. Okay. Yeah, that's great. So let's see how many people have joined. Okay, I'm seeing the numbers growing. Let's wait another 2 minutes before we start. Okay. Okay. So 50% of the people say they have read the book. That's great. And how many of you have purchased this recently? Yeah, I see Akash have recently bought this book, and I hope you have at least read the first two chapters that we are going to discuss today. Yeah, that's great, Shashank. So let's start. Let's start the day, and welcome to the session, guys. And myself, Archit, and I try to break things that so that you don't have to do that. So, with that in my mind, so this is my first live session, and I'm very excited to kick off the journey. In this session, we'll be discussing about one backend book. This complete session will be discussing about one backend focused book together, where we'll discuss everything about the book every Sunday, and we'll try to understand from the real world examples and map the learnings from the book. This session is on a book called Microservices with Co. Right? Okay. And that book is written by Alexander. Today's session, I'll be covering first two chapters from the book, where the first chapter is mostly focused on microservice versus monolith. Basically, when we have to choose microservice or when should we choose monolith? That's the question that he has answered in the first chapter. The second chapter is about best practices and a good code structure. We By the end of this video, we'll be taking one use case and building an inventory management app. And we'll try to understand all the trade-offs in the process of building that app. Because as a backend engineer, it's all about trade-offs, right? And you should understand every pros and cons of any decision that you're taking while designing your application, right? So let's make this interactive, and I hope you guys keep pushing questions on chat in case you have anything. So let's start by very obvious question that is monolith really that bad? Should we never use monolith? So this is a question that Alex has answered in the book and made it very beautiful for people who want to understand this logic in depth. So when would you choose a monolith? When does a monolith really make sense? It makes sense when your business logic isn't defined right now. Because if you start with defining microservices without you have a clear understanding of the business logic, you would end up redefining a lot of microservices, and it will be chaos in some time. Then the second use case is when you have a smaller team. You don't have a larger team to manage different microservices. So for those smaller teams, it becomes very difficult to manage microservices and debug them. The third use case is when you have ultra low latency requirements. So for example, stock trading applications. So there you cannot use microservices basically. The only reason is in microservice, there are a lot of network hops. So that's why the stock trading applications become slower. Then the final thing is that if you have slow moving parts where you don't have lot of changes that comes very frequently in your application, then microservice doesn't make sense. So these are few conditions when you would definitely have to choose my monolith application. Now, having said that, when would you choose a microservice? When does a microservice make sense? So your microservice will make sense if you have a faster deployment cycles where you have probably every week you do a deployment or every day you are doing deployment. That is when you use microservice. You have different part that needs different type of testing. So for example, there can be parts where you need a rigorous testing, whereas some parts you don't need testing that often. So there you need microservice again. You need fault isolation. So if there is one service going down or one feature going down, you don't have to shut down the complete application, right? So that is one thing. Then, when your team wants to work on different component, you have a larger team where you can divide the teams to manage different infrastructure or different component of your application. Then microservices easy to manage. Then you have security and compliance related issues. So, for example, if we talk about the inventory management app, which we'll be discussing in this session today, in order management, when you are talking about the finances, you definitely need a different type of compliance as compared to regular inventory management, where you're just listing the inventory, right? So in this scenario, you will separate out the order management so that you comply with the order or money trail, right? Then you have apps where you are managing personal identifying information, for example, medical records. You want to manage that, you should actually manage that as a separate microservice where in case there is anything, any fault or anything, you isolate that part there and you have different compliance rules on that particular application. Then using microservice, you get a very different type of tech stack flexibility that you have. So each of these microservices can be on different tech stack. So these are few conditions when you would definitely want to choose a microservice. But having said that, software engineering is about trade-offs, right? So we need to understand the trade-offs of microservice. So basically, all the positives and negatives about a microservice architecture so that you can choose wisely. So let's start by discussing the positives about microservice. Microservices enables you to build faster and isolated testing, right? Then you have a freedom to choose different tech stacks. You have scalability in your hand. So in case you see that one part of your application is receiving more number of requests from the user, for example, in inventory management, you would definitely receive more requests in your order management, right? Where you buy and sell products compared to managing the items that you have in hand, right? So that's why you can scale your applications, different components at different scale. You can use different infrastructure there. Then the last part is being fault tolerant, right? So in microservice, if one service goes down, your rest of the application keeps working as is. So those are some positives. Now let's start by discussing some negatives about microservice. So in microservice, the major drawback is network overhead because there are different microservices. You would have to pass that one request through lot of microservices, and that is involving network hops, right? So your application's performance would go down a little bit. Then debugging is really hard. Let's be honest, if you guys have worked in microservice, you would have faced this problem where if you want to debug a particular request cycle and you want to see where it failed, you have to spin up a lot of microservices, and it's really very hard to debug that application. Then your CI/CD becomes again very complex. That is one more drawback of microservice. The final drawback that is actual very, very serious drawback is that your distributed transitions are very, very hard to manage. So you will have to plan ahead to understand how you can manage those distributed transitions. So, for example, there is an application where you are trying to store a particular information of user. For example, it is divided into two parts. The medical records goes into medical microservice, and basic information, for example, your phone number, email, goes into your user management. Now you will have to manage the transaction status within the two applications now. So that becomes a very real problem. And there are few infrastructure, or there are few things how you manage that, but it really is a pain there, right? Now drop a heart in the chat in case you are learning something new till now, because I'm seeing no response in the chat, and I don't know if you guys are really following along. So let's start by designing an inventory management app. So let's analyze its architecture uh, in detail. So, to design an inventory application, what are the different entities that you will have? You will have to list product, right? You will have to manage products. Then you will have to manage all type of orders, buy, sell, or return orders. And maybe someday you want to also introduce the discounts on your app, on your products, right? So these are few major entities that you will start with. Then things can go. Akash says that, yeah, to maintain atomicity of transition in micro difficult, yeah, it's really difficult to maintain atomicity of transition in microservice when that transition spans to a lot of different microservice. You will have to apply a lot of logics to maintain that atomicity in your transactions. Okay, coming back to our inventory application. Now, these are few basic entities you will start with. You can extend, you will have a lot of use cases in future, and you keep extending this, right? But let's try and focus on these three things as of now. Now, before we move forward, you should ask yourselves few questions. Where is the major complexity? What are the most frequent changes? Where do you need the scalability differently? So which service has to scale differently, right? Then what needs tight security? These are few questions you should ask yourself before you decide on whether you should use a microservice or monolith. Now, to answer these questions, let's start by answering few more detailed questions. Is there frequent updates to your order? Yes, because of government compliance. Orders have to comply to government's taxation and everything, right? So there would be frequent updates to the orders. Do order needs different compliance? Yes, the government regulations have to be there, right? You will have to comply to government regulations. Is discount flexible? Yes, discount should be flexible and should be low risk, because someday you want to have a discount coupon code that is tied to some influencer, or maybe someday you just give a flat 50% off, right? So your the discounting feature has to be very flexible. And then, is your inventory read heavy? Yes, the inventory flow is definitely read heavy, because there we will have less frequency of update operations. Once you have created an inventory item, you will not very frequently update that, right? So now, because we are discussing this book, I will definitely design this in microservice. But by answering these questions, you would also have understood that we will have to choose a microservice architecture for this application, right? Now, let's understand, because a language is always a syntax. It's about only syntax, then you get few things around it. But the clean code is about your mindset. So, having said that, you need to understand what are some good practices that you need to follow when you are writing a code in Golang. And I have listed few of these good practices that commonly seen people following up. And these were listed in the book, so I wanted to bring them up and make sure that if someone is still not following it, he should start doing it. So these habits are like handling errors before you do anything, right? You have a clean names. Do not repeat the package name in the structure or interfaces that you define in the package. Now, this piece is very important. For example, your package name is, let's say, byte, right? And then you have a structure over there. So anyone who wants to use this structure will have to append that structure name with the package name, right? Byte dot the structure name. So you don't have to add that package name in your structure name, because that will obviously be used by the user, right, of the package. So do not repeat the package name in your structures or your global variables there. You should always pass context as the first parameter of the function. Now, this is very important. Context passing is needed when you want to have a distributed tracing, right? You want to pass some user information, maybe from the request token headers and those things. So your context is really important. And then your context is also important if you want to have a timeout related functionality. So for example, your API says that we have a timeout limitation of 10 milliseconds or 10 seconds, let's say, right? So that context will have to pass till your database, so that if your API has ended, your database transaction also gets ended. It doesn't have to keep running in the background, right? So your context have to be passed, and it should be the first parameter of your function. Now, a single method interfaces should be named with the method name followed by an ER. For example, the writer interface that you see in Golang, obviously, where you only have one function, that is write function, and the interface name is writer. So you see the ER appended in the end of the interface name. So now these are few habits that I've not very commonly seen people following up, but few of them I also didn't follow before I read this book, definitely. So I'll tell you what. So one thing is wrapping the error with the context. This I've rarely seen people using. So people don't use the percentage W operator of the FMT there to wrap around some context to the error that is being returned by the function. I have seen people adding a lot of panics statements in their code. Now, panic is something that you should really avoid, because panic will actually stop your application completely. And if you don't have any mechanism to respan your service using Kubernetes or something, then your application is dead. So you should not use panic until unless you know that this scenario that you are handling is really making sense for the application to shut down. For example, memory leak, or for example, high memory consumption, or maybe there is security threat that you have identified in your application. You have written some logic, right? Those areas, panic makes sense, but otherwise, you don't have to panic every time, right? Your context should not be attached to structures. Now, this I've seen a lot of new developers attaching context to the structure and then passing that structure to the child functions. You should not do that. Your context has to be passed separately to all the functions, so that it is very implicitly mentioned that your context is important. If you add that in the structure and you don't assign value to that context in the structure, it doesn't make sense, and then you end up handling the null exceptions inside your code, right? Your context should not be attached to structure. It's a context leak case. Then you should only test your public interfaces. The internal or private functions should automatically get tested. Now, okay, Akash says, yes, the percentage W is something that you should use. Error F. Yes, that's correct, Akash. So I'll put one question on you guys. Tell me about no, okay. I am putting one question. Let's see if you guys have an answer to it. So the question is, tell me about one thing in your Go code that you regret now. I'll wait for next 2 minutes for that answer. Some context, okay. Yeah, that's a very common mistake that I've seen people doing, Akash. So at least you got one additional point that you will start improving now, right? Okay. Yeah, that's correct, Mukul. Misusing Go routines and channel. Oh, yeah, that is yeah. So the tech was that's really very important topic, and definitely I'll discuss that in my future videos. How to use Go routines and channel. It's really tricky, and if you don't follow the basic conventions, it will really mess your application, and you will end up having those deadlocks or race conditions again. So you really have to manage your Go routines and channel very wisely. That's a good point, the tech was. Okay. Okay. Let's move forward. So now, with all this in mind, let's start by understanding what are different type of folders that you can have in your backend application when you're using Golang. Akash says tight coupling of structure instead of interfaces. Akash, I would say that this is not limited to Golang. This I've seen people doing in .NET, Java, other applications. So people tend to understand the benefits of using an interface instead of directly tying their classes with the actual implementation. So when you use interfaces instead of actual implementation, you end up having a loosely coupled application where you have a good ability to mock your interfaces and have a good testing infrastructure now. So if you are still tying your application with the actual implementation instead of interfaces, I would say you should stop doing it and start using interfaces to have a good unit testing and your testing very robust. Okay. So about the backend folder structure. So any application in Golang is having few folder structure that should be followed. Now, why we should follow it? There is no rules, set rules by Golang team to follow that. But I have seen that if you follow this structure, it is easy for you to keep extending things. Yeah. So it is easy for you to keep extending your features, and your application becomes very robust and extensible. So few of those common use folders are CMD folders. That is the entry point. You define your main functions there. whether you are creating a CLI application or you want to create a gRPC application or you want to use REST, you define all your entry points in the CMD folder. That's one thing. Then you have an internal folder. Now, internal folder is very important because anything that is inside this internal folder will not be exposed to services that are outside my folder structure. So, for example, if you see on the right side, the inventory application you see there, anything that is inside the internal folder will not be accessible, will never be accessible by people inside discount or metadata or order application, right? So this is internal, which helps you keep your code safe from exposing to the external world. Then is package folder where you put all your reusable stuff which can be used by other microservices or other places. So package has to be having everything that goes outside. So for example, all your models which will be reused in your application in other places. So those goes into package. API folder where you will define all your open API spec. For example, your uh, Swagger documentation or any gRPC specs that you want. So those are just documentation related things that you put in API folder. Then one is test data folder where you put all your testing data. For example, if you're doing regression testing and you want to have some JSONs already prepared there for testing the API, so you will have those JSONs residing in the test data folder. Then there is a web folder where you define all your web application. For example, if your Golang is also spinning up your front end application, web is the folder where you will put all your front end application logic. Then you will have a lot of different folder, for example, any scripts, configuration, deployment related folders, and those things are very use case specific. Yeah. And usually, I would say that I would follow this same architecture in all my microservices so that I don't have to think twice when I start with new microservice, and I don't have to get uh, put my brain around on the infrastructure side on organization. Yes, internal package cannot be imported outside the module. You cannot use anything inside the internals. That's the specification by Golang. So anything inside the internal folder will not be exposed outside the module. That's correct. So by having these things in mind, I have I have defined few microservices for our inventory management application. And let me walk you through my understanding on why I had those few microservices. And you guys can fill in case you have a different opinion on that. So to start with, I have one application that is my metadata application, right? Now, metadata application is the place where I will have metadata of my inventory. Basically, my inventory name, description, any specification, your any codes related to that inventory, right? Your basically your manufacturer or all those warranty related information. Basic, what is the category of the inventory, whether it is perishable item, is it electronic item, is it book or something, right? So those basic things will be dealt by the metadata microservice. It will not take care of orders or inventory, number of items in the stock. Then second microservice is order microservice. Order microservice is responsible for any orders related to buying, selling, or return orders. So anything that you see when you are doing checkout process will be dealt by order microservice. Then there is a discount microservice, which is taking care of any discounts that you have active on your inventories right now. And then one service is inventory service. Now, this is very important. And in this service, I'll give you a detail of why this service exists. Now, inventory application is where your actual user will interact with. So for example, if your user on your screen wants to list all the inventory, this inventory application is the one that will receive requests from the front end. Now, this inventory application will collect the data from the metadata application. It will also collect the information from the order application on number of items in the stock, whether the items are out of stock or how many items are pending, left around in the stock, right? So those things. Then it will also get information from the discount, whether there is an ongoing discount on that inventory, particular inventory item, or maybe on the category. Complete category can have a complete discount, right, going on. So those things will be captured from the discount. And this inventory application will collect data from all these three places, combine that into one model, and send that to the user. Now, user will get a very clear understanding of what are the different items we have, how much items we have in the stocks, and is there any discount going on that stock. Okay. So this is basically what your different type of microservices are there right now, right? Now, in inventory microservice, you see an internal folder where you see a gateway folder specifically, right? Now, gateway folder is helping me to interact with other services. So now, by other services, for example, if you're using Kubernetes, you will have to use service discovery and identify the service endpoints and then reach them, right? You would have to call those microservices. So this gateway will help me getting there. So this is there. Then there is controller, which is actually defining all my REST endpoints, which will be exposed to the customer. So those endpoints will the actual handling of reading the data from the request or pushing the data to the request in the response will be taken care by code in the controller folder. Then is your handler where you actually apply the logic uh, to parse the request and get the request from maybe repository, or do you have to get that data from the gateway? So all those logics will be taken care by the handler, right? Oh, sorry, I just missed that. So handler is your endpoint where you define endpoint, and controller is where you apply the business logic. Sorry, I just gave you the wrong part. Yeah, controller will have the business logic where you should where you are you supposed to get the information from repository or gateway or wherever, right? So that is taken care by controller where your business logic is applied, and handler is where you define your endpoints. This is one architecture that I'll be following in all microservices. Now, there is a question. I'm a beginner. Can you tell me which architecture? This is a layered architecture where you have layers of handlers, then you have business logic layer and those things. So this is layered archi. Yes, Akash, you are right. The request will go from handler to controller, then gateway or repository in that scenario. Yes, that's correct. So by this time, I understand that you guys have a clean understanding of how we will define this. But before we wrap up, I'll give you one assignment where I have just created this folder structure in my Git repository, and I'll also publish these notes and the PowerPoint presentation there. What I want you guys to do is you fork this repository, add the code logic, and and create a pull request for me. I'll review each and every code and see whichever is the best code. I'll give you my comments and feedbacks on your pull request. One code that I find that would be very good and close to understanding, I'll accept that code and merge that into the actual repository. So that's an assignment that I'm giving to you guys now. Now, let's wrap this up. So, in this today's session, we have understood that microservice is not the default choice that you make. Monolith is great when you have requirements around speed and less number of iteration, when you have less number of developers and you don't want to have a lot of debug sessions, right? Structuring your backend for readability, not just for elegance. You should not structure your backend to just copy paste the infrastructure that you have seen in maybe Java or .NET applications. So Go has a different mindset, different framework, and everything is different over here. So you should not try and replicate what you have seen in other languages in Golang. It will really make your life harder if you do that. Being idiomatic in Golang is helping you to not have those moments where you say, "Oh, what is happening over here in my code?" If you are following the coding conventions that Golang official documentation also suggests, and popular libraries are also following up, then it will be very easy for you to maintain your repository in long run. Now, by this, we have come to the end of the session today. I'll open the ground for next 10 to 15 minutes for you guys to ask me questions. And in the next session, which will be again coming Sunday at the same time, 12 o'clock, we'll be discussing chapter 3 and chapter 4, where chapter 3 is about service discovery and chapter 4 is about different type of serializations available. So then understanding serialization will give you an understanding of what type of serialization you should use in your application at what place. So not every serialization is good for any use case, right? You will have to choose the best one for your use case. Again, that's a trade-off. So we'll understand different type of serialization and we'll understand how we can use service discovery using Kubernetes. Right. Now I'll open the ground for next 10 minutes to 15 minutes for you guys to ask me any questions or any doubts that you have in your mind. And just a disclaimer, I know that today's session was more of theory. Trust me, the initial few sessions of any book reading, because we are building up on the intuition, we are building up on things, it will be little bit of theory. And after the second or maybe third session, we'll start with actual implementation of code, where you'll have a lot of codes coming up, and you'll have very good interaction on with the code now. Akash says, can we have order service as client facing which will interact with the product metadata, inventory, and discount? Akash, I would not want to do that, considering the security risk, because your order management or order service will also take care of payments, right? Payment gateway and all those service. Maybe payment service as well. Okay, you're saying that you want to introduce a payment service, separate payment service. Then also, I don't want to expose my order service directly to the user, because that's a security risk. Because if that application is exposed, you might have a lot of requests coming in which might mess around with your data. So securing your order service behind inventory service is something that I would rather choose. But it's again a design decision that you can choose. If you want to expose the order service directly to client, you can go ahead and do that if you have applied the right security there. And payment service is definitely something that will be directly client facing, where you will generate the URLs for redirection to the payment gateways and getting back from the payment gateway. So payment service will be there, but I've not included that in my current architecture, because payment is a separate consideration altogether. Okay. Any other questions? We still have times to answer. And yeah, and also I'll share the notes also in the GitHub repository, and the GitHub repository I'll attach in the pinned comment of this live session, and also share that in the in the LinkedIn event, that repository, so that you guys have access to it. But I'll need another 2 hours or 3 hours to publish that. So I'm working on publishing it in a well-structured manner, the notes, right? So in next 2 hours, you should have access to the notes and the PPT as well. So I have launched a question where I want your feedback on, is there any suggestions that you guys have for the next session? Maybe if this session was having something that you want to improve or you didn't find good, you can put that in the answers, and I'll try to keep that in mind in next session. Okay. Okay. Okay, let's do one thing. Let's end the session now because I think that we are done with the questions or any doubts also. And in case you guys have any doubts, you can keep putting that across in the comments of this video. I'll keep answering them. Right? All code from beginning. Yeah, that is something that I'll be trying to do. But having said that, Mukul, it's really hard to do that if there is a long code that you have to do, right? In the session of 1 hour, I cannot write a long code. Maybe I'll try to do that for smaller piece of codes next time. That is a good suggestion that I'll definitely work on that part. Okay, so let's end this session today. And in the next session, I will have exactly on next coming Sunday at 12 o'clock, where I'll discuss chapter 3 and 4 of the same book. And yes, this is a very important thing. We have me and D Tech Works, we have planned a podcast that is coming up soon. So you guys, I would suggest you guys to stay tuned to the Techverse and my channel so that you get to the podcast. And the podcast is aimed towards backend engineering and Golan. So it would be really helpful for people who want to transition their careers to either backend engineering and start with Golan as their primary language. Yes, Akash. Next time, the sequence and diagrams will be there in case, yeah, today's session was more about a very basic theory. So I doubt there were any requirement of diagrams, but yeah, next time I'll keep that in mind. Sequence and diagram flow, data flow. That should be something that I'll focus next time. Thank you for the suggestion, Akash and Mukul. Okay. So see you guys next Sunday, exactly at 12 p.m. IST time, where chapter 3 and 4 will be discussed. So, bye, guys.